All right. And hello, everybody. So, man, it has been a moderately slow week in the Gen AI space, but it has been an incredibly interesting week in terms of everything that's happening in the world, right? So, I know you guys are probably worried about like tariffs and declining stock market and the potential World War III, but don't worry about any of that, right? Because we are going to we have been searching, looking through the news, looking for all of the best things that you may have missed throughout the week. So there's like, I know, like you're probably worried about all those other things, but we have some actual Gen AI stuff to talk about. So don't you worry. So yeah, Shashank, do you want to get us started with the Gemma models?
Sure, yeah. So this is continuing the trend of open source, really pushing the boundaries of what is possible on like the small scale, running locally on tiny devices closer to the edge, as opposed to spending tons and tons of money deploying large, extremely expensive models on cloud servers somewhere that are proprietary with closed weights, and you have no idea how they work. So this recent announcement is from Google's Gemma model series. So maybe we can present some of the benchmarks here. But yeah, they've announced a new set of family of models, foundation models that rival some of the best models out there. So the Gemma 3 model is tiny. It's 27 billion parameters large. For context, the DeepSeek V3 model, which is the previous best open source models, was 671 billion parameters big. But to be fair, that was a mixture of experts. And at any given time, only 20 something billion parameters were active. So make with that what you will. But I think Gemma 3 has been able to pull off the same amount of performance on a much smaller size.
Is Gemma a reasoning model?
Uh, I don't think it is specifically a reasoning model, but it does have some reasoning capabilities. Um, they didn't specifically drill down on its reasoning capabilities, so I would hazard a guess that no, it is not a chain of thought reasoning agentic kind of model.
Okay. So it wouldn't necessarily be completely comparable to DeepSeek because DeepSeek I thought is the reasoning model. Or actually, I should
Well,
take that back. DeepSeek is not a reasoning model, but DeepSeek R1 is a reasoning model, right?
correct. Yeah, so DeepSeek is the parent company within another parent company, but they have a couple different models. V3 is their regular generative model, and R1 is their reasoning model, which runs multiple token generations, evaluates its own responses, and then refines that answer to give you something more comprehensive.
Okay. Yeah. And actually, I said reasoning model, but I know we're talking about a lot of stuff. So I want to keep the listener, I want to just have some definitions just before we kind of go any deeper into this conversation. So what we're talking about here is we are talking about models, right? They are LLMs that can answer questions, right? Now, there are different types of LLMs. The one type of LLM is kind of what you call maybe a single shot model, where you ask it a question and it gives you a response. So, for example, I might ask, how tall is Mount Everest? And it would respond, actually, I don't know how tall Mount Everest is, 21,000, 37,000, however tall Mount Everest is. It would respond just with one answer. Whereas the reasoning models, you would say, hey, what do you think about my stock portfolio? And then it would go and then think. It's like, oh, well, it looks like you have a lot of investment in Tesla. Maybe that is too much. Maybe you should consider selling a little bit of this. And then it'll sort of ask itself some additional questions, think for a while, and then give a response back. So to summarize, these single shot models, you give one question, they give you one answer very quickly. The reasoning models, you'll ask it a question, it'll think about the question for a while, and then it'll give you a response. So Gemma is the first type of model, not the one where it thinks about things for a while, but you ask it a question, it gives you a response. So Gemma is cool because it's able to handle not just text, but it's able to handle multimodal input. So what that means is you're able to put in a picture. So for example, I could take a picture of something and then Gemma could interpret it for me. So actually, I want to share my screen because this is a video podcast. So let's do that. So right here in the Gemma page, they showed a picture of a Japanese remote control. So actually, fun fact, I am in Japan right now and I'm learning Japanese. So this right here is super useful because I actually just last night was trying to turn on my air conditioner and I was trying to heat, but it just kept on making the room colder. So if I would have had something like Gemma where I could have taken a picture of a Japanese air conditioner remote, I could have actually figured out how to keep my room before freezing for a little bit. But yes,
Yeah,
Gemma is able to handle these types of pictures. So in the picture, so for the audio listeners, it's a picture of a remote, and then the remote has a bunch of the Japanese characters on it. So it shows a bunch of the characters to say like, I want to heat the air, I want to cool the air, turn on the air conditioner, turn off the air conditioner, raise the temperature, lower the temperature, stuff like that, right? Your standard remote control type things for your air conditioner. But since it's all in Japanese characters, as a Westerner like myself, it's pretty hard to understand exactly what they all mean. So Gemma.
So the really cool thing about this is that not only is it multimodal, it can understand the images, it's also multilingual with a support for like 140 languages. And that is across all the sizes except for the, very tiniest 1 billion parameter size. So everything from the, I believe like 4 billion parameter up until the 27 billion parameter can do multilingual and image, which is just wow.
Yeah. And it also seems like it has done pretty well on the benchmarks as well, right?
Yeah, we can talk a little bit more about benchmarks. I have some opinions on how they can potentially be gamed. But yeah, so far it is a state-of-the-art model, definitely a state-of-the-art at its size, but also compared to some of the frontier models out there.
Okay, cool. Have you tried to use it yet?
Not yet. I was actually looking at LM Studio right now to see if I can download the 12 billion parameter model because I have the very smallest base M1 Mac. And I think 12 billion is like the limit of what my laptop can handle. And even at that size, it's not going to generate things as quickly, but it'll be reasonable if I want to use it offline.
Yeah. And actually, one thing that's also interesting about Gemma from this article is in the article, it showed me 3 different techniques that they were able to use to train the model. So I actually wasn't aware of all these abbreviations, but now I'm gonna share them with you. So they use 3 different types of post-training techniques to train Gemma. Post-training meaning like at the end, they did 3 things. One is they did RLHF. RLHF is reinforcement learning from human feedback. Basically what that means is you give a model some question, and then the model gives you a response, and then you have humans say, what do they prefer? So for example, I might say, hey, my back hurts. What should I do, Gemma? And then Gemma might give 2 different responses. It might say, one, oh, do nothing, just, rest and take it easy. And then the other one might give
So
be a
for
response.
context,
Yeah.
the RLHF technique was the groundbreaking technique that ChatGPT used way like 2 years ago when it first came on the scene. And that is really what it pushed the first generation of LLMs to reach the amazing capability that they have today.
Exactly. Yeah. So really, you're just trying to get whatever the humans prefer. So humans as in us, what do we prefer? So you're really kind of guiding the model to be pleasing to a human, not necessarily correct, but pleasing, right? So going back to the original example, I might say, hey, my back hurts, right? Like, what should I do? The one model might say, oh, you should rest and do nothing. And then the other model might say, oh, here's a bunch of physical therapy that you can do to solve your back problems. And then the other one said, maybe there might be a third option to say, oh, there's absolutely nothing wrong and just do nothing, right? So maybe like one human might say, oh, I really like the idea of resting, even though a doctor might say, oh, maybe you should do these physical therapists, or maybe a third option or fourth option might say, oh, you should just, don't ask me, I'm just an LLM, you should go see a doctor. And then the human would have to decide what is the quote unquote correct response, right? Now, this is highly debatable, right? So you're not necessarily having doctors do the RLHF on this. This might be somebody who works at Google, who
Although
works
you
at one of these
could,
tech companies. You
could potentially have domain experts do RLHF on a specific, set of questions or a specific benchmark to optimize the LLM's performance for that specific use case.
Yes, but it's not guaranteed that you actually are getting domain experts to do RLHF on that. I mean, you could. I mean, that'd be nice, but you may not necessarily get that. So then, all right, I think we've explained RLHF enough. Then the next one that Gemma is using, which I think actually DeepSeek also used something very similar, which is RLMF. So remember, we have RLHF, reinforcement learning with human feedback, and then we have RLMF, so reinforcement learning from machine feedback. So what does that mean? That means that you have not a human give feedback, but you have a computer itself give feedback. So that would be something like, hey, why don't we ask the model something math related, and then we have it try to run through the calculations and then see if that math solution is correct, right? So for example, maybe I have a known working solution. Maybe I have some sort of calculator. Maybe I have some sort of simulation that I can use to check the answer. And then I have the model independently generate that, right? So then what I could do is I could try to improve the model by comparing it against my calculator, by comparing it against my simulation, whatever, right? So there you could have the model kind of self-improve. Does that make sense?
Yeah, that absolutely makes sense. I think another word for it is RLAIF that was used elsewhere. And I think a couple of the other competitors of OpenAI use that approach because it's a lot easier to scale. You don't have to hire manual people to manually go in and annotate your data or like compare, okay, this response is better, that response is better. At scale with millions of examples, that quickly becomes very expensive and very unyieldy. So I think a couple companies have resorted to that approach, and definitely the open source models to try to bring down the cost and provide these models for free have resorted to use that approach.
Yeah. And then the last one that it seems like Gemma was using was the reinforcement learning from execution feedback. So this one is very similar to the math one, but as opposed to using a calculator, they are using this specifically for programming, where you would run the code and make sure it executes. So you would make sure the code compiles, you would make sure, and then if it didn't compile, you would probably feed that into the model again, and then have it tweak its parameters so that hopefully in the future, it gets really good at programming, and then the code that it outputs would almost always compile. So to summarize, as we may turn this into a short later, reinforcement learning from human feedback is when you have the humans decide what they want to do with the model. The reinforcement learning with machine feedback, RLMF, is when you have a model that is improved by using mathematical reasoning and you have it call something like a calculator. And then the last thing is RLEF, which is reinforcement learning from execution feedback. It's where you have a model output code and then you try to run the code. And then each of these, the model tries to make it so that it is able to do well at those particular tasks. So for RLHF, you're trying to align your model with human preferences. RLMF, you're trying to get really good at doing math problems. And RLEF, you're trying to get code that compiles.
Yeah. And again, I think a lot of these things are very new terms that have been coined. I don't think these words existed or these acronyms existed more than 2 years ago. RLHF was the first one. I don't think RLMF is a widely used acronym. I was familiar with RLAIF, which is similar, but I think a slightly different concept where they use another discriminator model to kind of give feedback on the main model's responses to kind of critique and evaluate whether or not this is a good response or not. And in this context, it seems like Google's Gemma is using machines, AI, to specifically improve the performance in mathematical reasoning, which is interesting.
Yeah, so it's pretty cool. And I think that I applaud Google for doing this because Gemma, I believe it's all open source, right?
Yeah, it's all open source.
Yeah, and that's awesome, right? So the fact that these big companies are coming out with open source models is awesome, really.
You know, I go ahead.
Oh, I was just gonna say a lot of the other big companies aren't coming out with open source models, OpenAI, but the fact that Google is, I applaud them.
There's like a constant irony in OpenAI being the one major company that has consistently kept its models and weights closed, except for maybe like one of the early GPT-2 models that I believe they open source. But most of the big competitors, Microsoft, Google, maybe it's because they do have other sources of revenue. They don't need to rely on these models to sustain their entire business. And they're able to put out these models to maybe build goodwill with the developer community. And another strategy, I really think open sourcing has really benefited Meta because now most companies are using, for the last 2 years, I think most of the open source community has been using the Meta's Llama models to fine-tune them, improve upon them, build cool new applications. And then in return, Meta has been able to take these improvements on the Llama models and then incorporate it back into their research, into the next generation of models to make them even better. So I think there's a lot of benefits to open sourcing. And even apart from just the models themselves, like you have to run these models somewhere. They run on physical hardware, which has a lot of practical constraints. Just because you have a model, that doesn't mean it runs everywhere the same. The model will run differently on an NVIDIA GPU versus an AMD GPU versus a Google TPU. It all depends on the model size, the parameter count, the amount of memory that it's using, how much bandwidth it needs to move weights back and forth in order to, do the inference to generate the words, the tokens that you see. So I think all these models, they optimize for a specific kind of hardware so they can get the biggest bang for the buck. They can use one single GPU to its fullest. Google historically has used its own internal TPUs because, Google has been doing ML for a long time for its search, for YouTube, for Google Maps, for a bunch of different products that serve billions of users. All of its AI has been optimized for TPUs, not for NVIDIA GPUs, definitely not for AMD, but for TPUs. So to take a Google model and run it on an NVIDIA GPU hasn't always been the best strategy. But this specific one, they mentioned that the biggest Gemma 3 model, which is only 27 billion parameters, I think you can run that on your MacBook, Mark, like the M4 Max. And it should be able to run the entire thing relatively quickly. But on the H100, it can run on a single GPU. And let me maybe quickly present this chart, which I thought was really interesting. It shows how many GPUs it would take to run the entire model. So Gemma 2 over here has like this one little dot.
For the listeners, right? So we are sharing our screen right now, but Shashank is sharing his screen and he's showing the comparison of different models. So it's a graph, it's a bar chart where it has DeepSeek R1, Gemma 3, DeepSeek V3, O3 Mini, Llama 3, Mistral Large, and Gemma 2, and how many GPUs are required to run each particular model. So
it's an interesting chart that lays out the performance in the chatbot arena Elo score, which is a public benchmark where random people vote on which model they prefer, and it gives each model like an Elo score, like how in chess you have a score for people to compare themselves against other people by playing matches. You win some, you lose some, and depending on that, you get a certain score. So it's the same with these models. And on the other scale, they list out the number of NVIDIA H100s required. H100 GPUs, which is, as of today, the best publicly available GPU that you can purchase today. NVIDIA does have some other GPUs, the Blackwell series, the B100 announced, but I don't think they've started selling those yet. And of course, Google has their TPUs, but individuals, companies even cannot buy it. So this is the best GPU that you can buy, the H100. And only Gemma in all of these models listed can run the entire model on a single GPU. Mistral, which was also one of the best models maybe last year at some point, the Mistral Large, which is their state-of-the-art offering, needs 4 of these GPUs. The biggest Llama 3 model, which was at one point
model.
That's right, Meta's model, which was at one point the best open source model, needs, like 20 GPU to run it. And ironically, DeepSeek, for all of its hype and popularity, I think it needs, I'm trying to count the dots here, 40 GPUs. And remember, like each of these GPUs...
right? Because I don't know, that doesn't pass the smell test for me, because I thought that, because on here it says this is 671 billion parameters that is needed to run, but my understanding is that for DeepSeek, it only runs like 30 something billion at a time, which I would think you could probably do on like 1 or 2 GPUs. I don't know who's running all the parameters at a time, but I question this graph to say that, oh yeah, Gemma can run on 1, which is probably true, but that DeepSeek cannot run on that you need like 20 GPUs to run DeepSeek. I don't think that's true. I've seen videos of people running DeepSeek on like, I don't know, a couple Mac minis. So I don't know if I buy this.
Well, for reference, I think maybe this is to run the model with a specific tokens per second output, because I think you could. Yeah, that's a good point. Actually, I don't know.
Yeah, I mean, maybe. Yeah, because
we'll fact check this. Well, for our listeners, we'll try to fact check this and then comment on this maybe in the next episode or in the show notes.
Yes. So we'll find out. But I mean, I don't want to say that Gemma isn't really efficient and then maybe it's even more efficient than DeepSeek. But I don't know. To me, it looks like there's some funny business going on in that particular chart where I don't know how they're running DeepSeek, but it seems suspect to me that you would need so many GPUs to run it. I don't know. I don't buy it, because the fact that they're able to have their top of the line API for DeepSeek costs, I forget how much it costs. It's less than $1 per million tokens. So it's super cheap. So DeepSeek would be losing tons of money if they needed that many H100s to run it. And I also thought that like that was the whole point of DeepSeek, was that like they're really efficient. So the fact that you would need to have all these GPUs, which I don't even think that the DeepSeek company was able to get a hold of all those H100 GPUs because they're illegal in China. So I don't know. I don't know if I buy that.
Yeah, so I'm looking at a blog post that outlines the GPU system requirements for running DeepSeek R1. And they have a bunch of different variants from R10, which is not the fine-tuned version. Excuse me. The various distilled models of various sizes, but the biggest DeepSeek R1 final model at its full 671 billion parameter size requires like 1,500 plus gigabytes of VRAM, which equates to about 16 A100s. I'm not entirely sure what that translates to in terms of H100s, but
I mean that's a lot.
yeah,
That's a lot of VRAM, because I think it's like, for reference, I know we're throwing a lot of numbers around right now, but roughly, if I remember correctly, the size of the model, right? So if you have like roughly, let's say, a 7 billion parameter model, that's gonna I think you like roughly need to double your VRAM that you need to run. So I think that's like the rule of thumb that I heard. So I think it's different for every model, but roughly, like, you take the number of parameters in your model. So like the parameters is roughly the size, and then you take you double that, and that's roughly the amount of VRAM that you need in gigabytes. So like, and this is not RAM, this is VRAM. So this is specifically the GPU's memory that is needed. So I think, for reference, the 4090, which is NVIDIA's consumer grade, like top of the line graphics card, I think that one has like 24 gigabytes of VRAM. So, and that's like a $2,000 GPU. So if you need 1,500, I mean that's a lot of GPUs
yeah.
that
So
you need.
I think without overwhelming the listener, I think all this boils down to the fact that a lot of the times you need to be a little bit careful when reading some of these charts and graphs published by one specific company pushing their specific model, which kind of brings me to another point that I wanted to mention in this podcast, which we were going to get to a little bit later, but I think now might be a good time. Benchmarks are often not representative of the entire model's capability and don't often represent the full picture. It's funny because when I looked at the Grok 3 announcement, it was by far the best model, the best ELO score, the best performance in a lot of benchmarks. And I was watching a video recently from this amazing channel called ByCloud on YouTube. I think it's a college kid who
ByCloud?
BYCLOUD by
Okay.
Cloud. So it's like this Gen Z creator with a lot of meme content, but the actual substance is pretty solid. He researches the latest models in depth, goes into the technical details pretty well, and he pointed out that the Grok 3 charts that were showed at the announcement were extremely skewed in the y-axis. So they compared their performance to some of the other models and showed that the other models are at, like, let's say 89% proficiency, and the Grok 3 was at the 93, and the Grok 3 reasoning was even higher. But like the height discrepancy in the visual chart was just nonsensical. It wasn't consistent, and they skewed it intentionally to make the Graph 3 model seem taller than the actual scale. So even though at 90 something percent, they should have been closer to the next best model, they intentionally made the graph a little bit taller to seem a lot better than they actually were. So our listeners, you need to be really careful when looking at some of these charts and graphs, and take it with a grain of salt. Although it is very impressive, it may not be as world-changing as these companies claim them to be.
Yeah, I think I saw that particular graph, and I don't know if this is the one you're referring to. So I'm gonna share my screen, and let me put this here just so we could share with the video listeners who are listening to this. So I believe it is this one. So I found this graph. Is this the graph that you're referring to, Shashank?
That's the one.
Okay. Yeah. So I'll just try to like briefly describe this. So this is another bar chart where they are showing different scores on a particular benchmark. So they're comparing the Grok 3 to the OpenAI's model, and then the Google's Gemini top of the line model. So they made it seem like Grok was winning in all of the benchmarks, but in reality, I don't know how the heck they decided they were going to come out with this particular bar chart, but
Yeah.
Grok 3 is the biggest, or it's like the longest line where I think like the goal is to get to 100%. So it shows that Grok is like 96%. And actually, I think they showed themselves as losing to OpenAI. But regardless, it showed that Grok was the biggest, best model. But they also showed the preview model that was unreleased. So they're like, okay, this particular darker blue line, this is the model that's released, and then this little light blue on top of that dark blue is the unreleased model. So it's like, what are you doing, Grok? It's like nobody can actually use that model, so we just have to trust you. And I mean, I don't think they're lying, but I mean they could be. Right?
They
like,
could very well be lying. Yeah.
Right? So
yeah,
I'm not claiming anybody's lying right now. But the fact that you just claim that on your unreleased model that nobody can see that you happen to have the best benchmark, I don't know. It seems like there's maybe a little bit of an incentive to lie there. So
and also even if you're not lying, misrepresenting the truth can be like severely confusing, because you could spend just like O3 high with O3 with a lot of compute did to solve the ArcAGI benchmarks. You could be spending $2,000 per query to achieve this benchmark. But is that something feasible to deploy and serve to customers? No, absolutely not. So if you're comparing a model that is open source like DeepSeek that can run at pennies for a query, and compare that to something that is costing a ludicrous amount, I think that is misleading consumers and trying to make yourself seem a lot better than you actually are.
Yeah, exactly.
So should we talk about some of the other ways that benchmarks can be gamed?
Yes. Let's do that. So, yeah, it seems like there's actually a ton of different ways that people can game these particular benchmarks. So, Shashank and I, we were kind of brainstorming a few different ways that you could game benchmarks kind of before the show today. But one of the simplest ways that companies can game benchmarks is they can literally just train on the data, right? So some of these benchmarks are open where people know what the questions are. So you're not supposed to just show the model what like the question and answers are, but like you can, right? And there's no way, it's very difficult to prove that you were training on the benchmark. And if you were training on the benchmark, you can you can do really, really, really well on the benchmark. And there's a lot of incentive for these companies to say, hey, we're number one in the benchmark. We are state of the art. We're the best. But they're basically cheating by just, giving the answers first. It'd be like if you're a student and you just you don't learn any of the content for the test, but you just go and then train on the answer key for the test. And then you don't actually know anything, but you just remember like A, B, abaca, dadabaca, right? Kabacabaca, right? It's, imagine like a multiple choice test. Actually, I think there's a Simpsons episode where they do that, where they're not actually going and then training, not like learning the thing. They're just like going to like a song and they're just remembering like A, B, C, D, D, E, A, C, C, B, D, right? Like you could do that. And that's essentially what it's like to train on the benchmark. You're just training on the answers and you don't know anything.
So some of that would be like the obvious case. You have the answers. You can either learn the actual answers and use that as training data for your model, or you can learn the answer key and just see which order the answers are coming in. Although that does have some limitations. The test runners, the private test runners, if they rerun these benchmarks on those models and like shuffle the questions around, the models might get confused. But the models can even kind of account for that technique by reshuffling the answers themselves during training, or rephrasing the question in the training data in order to generalize for a broader set of questions in a similar data set. So obviously having the answer key is the best, but even if the training data is not one-to-one, the models can account for that by reshuffling the data, rephrasing it, and getting the models to generalize to similar yet different enough questions.
Yes. And as we were saying, you could train on the answer key. You could also just steal the questions too, right?
Yeah.
Because
so
go ahead.
I was just going to continue that train of thought, because similar to trying to cram for an actual test in school, even if you don't have the actual answers, if your teacher gives you the questions, you can just go out there, research it, and then understand what's going on and learn just those 4, 5, whatever number of questions in order to ace the test. So the model builders can do something similar. If they get a hold of the questions, even though they don't know what the answer is, they can get high quality human evaluators to create training data, to generate the answers for the models to learn what the right answer is.
Yeah, exactly. So you could go and then have the model just know that question, or you could even just have humans go and try to figure out what the ideal answer to that question is, and then feed that into the training data. And then also, I think that not necessarily gaming the test, but since all these models are training on the entire internet, it's very possible that you may just have the question and answer in the internet that you're training on, right? So if you're asking in your benchmark something that's really straightforward, maybe that I would find maybe in a textbook, or maybe on an internet post somewhere, or maybe on Stack Overflow, I might just not knowingly, but maybe unknowingly train on the benchmark. So not necessarily gaming the benchmark, but it's very possible that the benchmarks themselves just aren't that robust, and they may leak into the public zeitgeist, so to speak.
Yeah, I mean, if you're training your model on all of human information that is available on the internet, you're very likely to come across something close to any kind of training test data, or training benchmark training data. But even if you try to obscure the question and answers from the actual model providers, so let's say you have a private benchmark data set, and you're just calling OpenAI's API in order to test their latest and greatest model against your private benchmark. But the second you hit their endpoint, you're leaking your private benchmark data to OpenAI servers. Now, obviously, they may not know what the answer is. You're just calling their API, sending your question to get them to give you an answer. But the second they figure out that, this request is coming from this IP in this specific location, or even forget specific IP targeting. If they get a new question that they're not aware of, that they realize that the model isn't capable of answering well, they can just steal that question and then make the model improve its performance in that specific domain. So, yeah.
Yeah, that's true. That's true. But even though it's very possible to game these benchmarks, we're not saying that any company is gaming these benchmarks. We just say
I am saying 100% multiple companies are gaming multiple benchmarks for sure. I mean, just look at the impact that the DeepSeek announcement had on the entire stock market. There is no way an exec is sitting out there with hundreds of billions of dollars on the line and not pushing their senior engineers, their team leads to try to game or at least optimize for certain benchmarks.
Well, so yes, I think the incentives are there, but I am not calling out any companies. So don't sue us, because so we're not saying any particular company is gaming these benchmarks. We just say
that's fair.
That
yes,
the industry as a whole, there may be some bad actors who are potentially gaming these benchmarks, but we think that most of these top level research companies are probably doing things with the best intentions. Probably.
Yeah, I agree. I do think the incentives are a little twisted, as with all of life. But I do remember listening to a podcast with some of the leads of Gemini, specifically, I think it was like the chief scientist, but it was some of the execs with hands-on information on actually the model that goes out to customers. And they were talking about this specific problem. You can game a benchmark and try to hit like absolute top performance on a specific domain, or not even a domain, but a specific benchmark, which just has a limited set of questions that tests input output in a very specific way. You can game that, but that doesn't necessarily translate to real world performance that customers are expecting. Because if you think about Google, the scale at which it operates is Google has customers at such a scale that they need to please those customers. I don't think it's in Google's best interest to game a specific benchmark to try to move the needle. Maybe a smaller company, maybe a research firm that has its entire revenue, entire livelihood, entire valuation tied to that model's performance on a specific benchmark. Maybe they might have a higher pressure to try to game that specific benchmark. But I think Google cares more about delivering value to its cloud customers, for example, that do spend billions or tens or hundreds of billions of dollars paying Google for its services in order to solve problems in the real world. So, I think some companies might game benchmarks, but there's also other companies who publicly mentioned that it doesn't always translate to better performance for its customers. So that is a real drawback.
Yeah, that is a good point. Also, I wanted to sort of make an argument on why, even if these companies were gaming the benchmarks, I think that might be okay if the benchmarks are well designed. So I think that, sure, we may have companies that maybe have high incentive to try to do well in the benchmarks. But I think that if a particular benchmark meets your particular task, then it's completely fine. So for reference, right now, I am learning Japanese. So I'm in Japan right now. I'm taking Japanese language lessons. I'm doing that basically full time. I'm studying many, many hours a day, just, speaking, thinking, talking in Japanese. And
you're thinking Japanese too?
Well, barely thinking, but a little bit, a little bit.
Nice.
My Japanese is still very bad, but it's getting better every day. And I guess I kind of have to think in a little bit, but anyways, so for me, like I would be completely fine if there was a model. Let's say there was a Japanese language teaching benchmark where they just trained it on a bunch of Japanese teaching textbooks and they showed it how to speak natural Japanese. And if it was just being equal to the benchmark or maybe like the goal was to be equal to a particular Japanese teacher, like I would be completely fine if it didn't exceed Japanese teachers, but if it just became a really good language tutor, because for that particular task, it's something that is well documented, or it's a solved problem, right? Like if I'm learning Japanese greetings, for example, right? Like there are probably billions of examples online, in person, on videos, on TV, or people are saying hello to each other, right? In Japanese, right? So, and if the benchmark was saying like, hey, how good are you at teaching Japanese greetings? Well, it's kind of like a cookie cutter type thing, right? Like any Japanese teacher is probably going to teach Japanese greetings in a similar way. And then you could probably say that for most concepts, where it's able to do a lot of these language techniques in a similar way. So I think that if you have a benchmark that is tied to a particular use case, then I'm sort of okay if you kind of train on that benchmark to get really, really good at that particular domain or use case. In my case, teaching Japanese. And I would say that when I'm using these models, so I've been using the Claude 3.7, the Anthropics model, a lot to explain concepts to me for Japanese. It's amazing. It's so good. Like the textbook is actually really terrible at explaining a lot of these concepts because I'm like, what is this? What is that? And then it can just break it down and explain it to me as if I'm 3 years old. And it's amazing. So
just to interject real quick, have you tried the Google models? Because I know Google does have the best multilingual performance.
I have not tried for that particular use case, but I will try it, and we'll see. I mean, I haven't had any issues with the Anthropics model, so I'm just continuing to use that. But yeah, I'll try out Google and see if it's any better.
Yeah, because I mean, as you can see with this Gemma announcement, the Google's Gemma 3 model has support in like 140 different locales, different languages, and I think Google historically has been very invested in multiple languages translation. And the transformer, as we've mentioned a couple of times before, was originally invented for the task of translation, to convert a sentence, a paragraph, content from one language to another while maintaining the essence of the information without like doing a word for word literal translation, which kind of misses some of the context and nuance in a lot of languages. But yeah, I think benchmarks are definitely useful. That's not at all what I'm trying to say, and I don't think Mark is trying to say that either. I think benchmarks definitely help figure out if we're moving in the right direction, how to compare different models, and even for specific businesses, even individuals, I think you should have your own benchmark, even if it's like very rudimentary, very simple, even if it's just like a vibe check. You should have some systematic way to compare and contrast different models to figure out, okay, should I be using this? Should I be using that? To have a consistent, reproducible rubric in order to compare different models.
Yes. To kind of add on to that, so when we say vibe check, we mean you just go and then you use the model yourself for your particular use case, right? So benchmarks, I think what we're both saying here is that benchmarks are incomplete, right? So a lot of benchmarks are useful, but they may not be useful for you, right? So if you do a lot of programming, you may want one benchmark. If you do language learning, if you look up history, if you're trying to do, I don't know, whatever, right? Like there's different benchmarks that are good at particular tasks, but none of the benchmarks may have your particular use case, right? So for example, if you're McDonald's and you want to say how good is this AI at taking orders at my restaurant, right? A coding benchmark isn't going to help, right? You want to be really good at discerning the items on the menu and then maybe answering some basic questions about how good a food tastes. And if you're McDonald's, you should have your own benchmark. So if you're an AI and if you're trying to use these models and you have a particular thing that you're trying to do, you should maybe even consider having your own kind of bag of questions that you go and then feed to the model every single time to see how does it do at your particular task. And I think that is actually going to be far more valuable than any benchmark could tell you, right? So benchmarks are good because they're a set of tasks that people can try in order to see how good a model is. You can use compared to any other model, right? So that's good, and it can give you a good sense of how smart a particular model is, but the benchmark is never going to be tuned to exactly what you want in a model. So I think that's a key takeaway for anybody who's listening, that you should have like a couple of questions that if you could access these models, just spend like even 10 minutes with the model and then just see how does it do at answering your particular question and see if it does better than the last model. And if it does, you could consider using that model instead.
Yeah, oftentimes when I think of benchmarks, it's not so useful when I'm doing things for like my day-to-day use cases. For that, I just use the best model. The best model that I can afford, the best model that I can pay for, the best model that's available as of today. Where benchmarks really shine is when you have a business use case where you're trying to optimize a specific workflow, solve a specific problem, and then you start thinking about, okay, how much do I want to pay for this feature? How can I reduce the cost for this specific task? Can I use a quantized model? How low can I go? Can I use the open source Gemma model, for example? Or do I need reasoning capabilities? So for those kinds of use cases, you really want to optimize the cost, the performance, the accuracy, and that's when a benchmark really shines. But kind of switching gears a little bit, benchmarks measure certain things in certain domains, in certain verticals, but there are times when you can't consolidate all of your requirements into a benchmark, which is where the vibe check comes in. And one of the most popular online vibe checks is the chatbot arena, which is just a simple website which shows you two models. You ask it a question and it gives you two responses, one on the left, one on the right. And then you vote. You do like this one, do you like that one? And they do this a bazillion times for all the models that they have access to. Obviously, all the publicly available models, some of the open source models, some of the proprietary models that are available through API. And they partner with companies on unreleased models to not only test the latest and greatest models that are going to come out, but also give companies feedback on their next generation of models in order to improve the performance. So that allows us to get an overview of all of the models out there with a vibe check of all the users. So we can see.
So I'll share my screen for the video watchers so you can see kind of what this looks like. I don't know if this is the one that you're thinking of.
That's exactly the one. Yeah, we can see the top leaderboard. Maybe you can call out some of the ones at the top there.
Yeah, so just for the audio listeners, I just started sharing my screen and we just took a look at the chatbot LLM arena as Shashank had just described, where it'll try to rank each of the models, and then you can also have the models battle where it'll be side by side. You can pick which one you like the most. And right now, it seems like the number one model, actually, I feel like we could make this kind of fun, right? So I don't want to say number one. We should go up the list, and then we can have the audio listeners try to see what it is, right? Because I mean, the video the video watchers can already see. But all right,
Should we start from
so
number 10 or number
let's do
6?
number. Let's see, 1, 2, 3, 4. Wait, 1,
You
2,
can see on
3,
the left,
4,
number
5,
10.
6, 7, 8, 9, 10. Oh yeah. Okay, so starting with number 10 is the O3 Mini High. So this is the OpenAI's model that actually, I think the Mini High, is that the one that they trained specifically on the ARC AGI benchmark?
No,
I think they did.
no. I mean, that was the full O3 model. This one's
Okay.
the quantized mini model, and the high qualifier signifies that they've used a high amount of compute.
Okay. So that's OpenAI's model. And then the next one, number 9, actually, it's a 3-way tie for number 9. So 3-way, and the reason it's tied, even though the scores aren't exactly equal,
They're so close.
there's a confidence interval. So they're like really close. So it's like, all right, well, these are like super close. So we'll just say they're all equal. So there's a 3-way tie. It is the Qwen 2.5 Max model. So that is Alibaba's latest and greatest model.
They've been doing amazing work.
Yeah. And it's open source too, which is cool. And then it is the O1 preview model. So that's actually, I think O1 preview is older than O3. Is that right?
Correct. But it's like, there's a lot of nuance. One used to be their best reasoning model. 3 is going to come soon, but the O3 Mini is something that they released. And so it's kind of very tricky to figure out which one to use. The O1 preview, it's really good, but really big. It's a massive full model, and it's very expensive. The O3 model is also very good, very massive, not released yet, but they released its mini version, which is reasonably good, but significantly cheaper. So for most people, if you have any kind of reasoning task, you should probably use the O3 Mini. But there's a little bit of nuance.
Because it's way cheaper.
It's way cheaper.
Yeah.
Significantly cheaper.
And we realize that these names are all terrible. They're all so hard to understand.
Oh my
yes.
God.
So yeah, it's like, oh yeah, O3, you would think it'd be better because it's like a higher number, but it's O3 Mini.
Mini, yeah.
Whereas like the O1 preview is the bigger model, and then, but it's, I don't know, but they're pretty close to each other. But then like O1 is more expensive, but only marginally better. So I don't know.
I think that accurately captures the difference and the significant variance in all of these models. Just because the numbers bumped up one version, that doesn't necessarily mean it's better. Sometimes it's just a little bit different. So always do your own vibe check, do your own benchmarks to see if it fits your use case.
Yes. And then also, I think I skipped it, is the Gemma 3 27 billion parameter model. So the one that we're just talking about this whole time, that's also tied for 9th place. Okay. Then, now, since we had 3 that were tied for 9th, now there are 3 that are tied for 6th place. So we have another O1 model, but it's an older version of the O1 model from OpenAI. It is tied for 6th place. And then also tied for 6th is the Gemini 2.0 Flash 001 model. So that is one of Google's highest models. And actually, I don't know, Shashank, do you know the difference between the Gemini 2.0 Flash 001 and then the Gemini 2.0 Pro EXP-0205?
So similar to OpenAI's regular models and the mini suffix, Google uses the Flash name to signify the smallest models, which are the cheapest, they're the fastest. The Pro is a little bit bigger, but not a little bit. It's significantly bigger, It's more expensive, and obviously it's going to take longer to generate the tokens. And they used to have an ultra model as well, which was massive. But I think somewhere in the last year or so, they've kind of given up on that, and we haven't seen any updates on that product line in a while. So you can think of the Flash as the tiny, cheap, fast model, the Pro as the bigger, more expensive, slower model.
Okay, cool. So then also tied for sixth place is the ever famous DeepSeek R1. And DeepSeek R1 is the top open source model. Of all the models, this is number one open source. Everything else that is higher is a proprietary model, which we can't actually see the source code. So DeepSeek R1, top dog right now. So in terms of open source, China is number one, DeepSeek. So congrats,
For the vibe
DeepSeek.
checks, at least. Yeah.
Yeah, exactly. Although all of this is really close to each other, right? So to say that DeepSeek is the best, it's like it's kind of marginally better than the next thing.
And we'll talk a little bit about the limitations of this vibe check too. But yeah, let's continue down the list.
So yes, now tied for third place. There are three models tied for third place. So there is the Chat GPT 4.0, which is OpenAI's older model. So actually, I don't know. I know that GPT 4.0 came out after Chat GPT 4. And my understanding was that GPT 4.0 was very similar to Chat GPT 4, but it was just a little bit cheaper to run. But it seems like on this, it's actually performing better as well, which is nice.
Yeah, I think it's just a little bit better. It's referred to as GPT-4 Optimal, I believe. So I'm sure they've improved performance in a variety of aspects.
Yeah. Okay. So then also tied for third is the Gemini 2.0 Pro EXP-02-05. So
it's the latest experimental. It's the latest and greatest, the biggest, most expensive, slowest experimental model from Google.
Okay, yes. And I assume that -0205 is February 5th.
I believe so, yeah.
Yeah, so it has the model name, which is Gemini from Google, 2.0 Pro, EXP. What'd you say EXP was again?
Experimental.
Experimental.
Because they're still working on it. And they removed the experimental tag once they've, I think, gotten enough testing, because a lot of complaint from users was they have to wait a long time between updates to these models. And Sam Altman at OpenAI kind of acknowledged this issue, and he mentioned that there's going to be more frequent releases with incremental updates, and they're going to get more feedback from end users about how these models perform in the real world, so that they can incorporate that feedback before releasing the next model.
Okay, and then lastly, tied for third place is the Gemini 2.0 Flash Thinking Experimental 1-21. Yes, I love how all of these companies are just really working hard with their branding department to make these models wonderful and memorable. I know we've probably lost like 90% of the users as we're going through this list. So if you're still listening, thank you, because you are the true nerd on this. But yeah, I don't know if this is interesting content at all, but I think
we can try to summarize our thoughts. We can try to summarize once we finish the list.
Yeah. So anyways, and then tied for first place. So I don't know, Shashak, we get a little like a drum roll or something for first place. All right, cool.
Yes.
Tied for first place is GPT 4.5 preview. OpenAI's super duper expensive model is
As
number one.
expected, that is
Yes,
like 100 times the cost of some of these other models. So it better be at the top.
it better be.
It better be.
Then also the uh not to be left out, Elon Musk Grok 3 preview, which I don't even know if that's released yet, but maybe it's released on the LM Arena February 24, 02/24. It's hard to compete with the richest man in the world. Grok 3 preview is also tied for first place on the LM Arena.
Yeah, so maybe I can try to summarize what I feel when looking at this top 10 list. There's a mix of all kinds of models, from big to small, from closed source to open source, from one-shot to reasoning models, from older to like the latest, as of maybe a few weeks ago, preview, early access models. So it doesn't seem like there's a unifying theme here. But I do know that reasoning models are not suggested for like creative writing use cases. So it really depends. I think it would be interesting to break down this chatbot arena into specific types of questions to figure out, okay, what do users actually prefer these models for? I'm assuming if we kind of classify some of the questions that the people are asking into reasoning questions versus creative writing questions, we might get like a divide with reasoning models being on one side and one-shot models being on the other side. And it's no surprise that the biggest models are at the top. But I was a little bit surprised that like the Quen model and the Gemma model, they're tiny relative to I think the GPT 4.5 preview. As far as we're aware, the last known numbers for OpenAI's best models were about 1.8 trillion parameters large or something. And I mean, it's no surprise that's at number one. But in contrast, the Gemma is 27 billion parameters large, and that's not that far behind. So
So for
it's
reference, a
really
27
shocking.
billion parameter model that could run on any laptop, or not any laptop, but if you have like
The
a high
latest
spec
laptops.
laptop, yeah, that could run on it. Whereas Grok 3 preview and probably GPT 4.5, you would probably need $1 million in computer hardware just to ask a single query for it. So they're not comparable in terms of cost. And it seems like even though they're spending like, I don't know, 100 times more on inference, like we don't actually know, but based off of the pricing, it's probably somewhere like 100 to 1,000. It's probably like a couple orders of magnitude more that it costs to run. The fact that something like Quen or DeepSeek is able to run on so much less hardware is amazing.
Yeah. So we were talking about how Chatbot Arena is a vibe check, and that still has its limitations. Obviously, it's not that precise. It's just like a popularity contest with what users prefer. But even that can definitely be gamed. There can be companies out there that are going out and trying to suss out which model is theirs, which response is coming from their model, which response is coming from the competitors' models, and try to upvote their model, downvote all the other models. So it's been shown that
Wait, so
you can,
how does that work? Like, how
yeah,
would
so
you go and then upvote your own model?
exactly. So it's been shown that you can watermark a model with a very high accuracy, like 95+% accuracy, and know exactly which response is coming from your model.
Wait,
So
so
that,
sorry, like a watermark, that would be because I know like you can watermark images where you would have maybe your logo in a corner or something, right? But if it's text, how do you watermark a model? So it's like you have like a different model that goes and it's like another AI model that can identify if the response is yours just by the way it responds. Is that right?
I'm asking Gemini 2.0 Flash as we speak, and while it gives me a breakdown, I'm gonna first try to give my thoughts on it. I would imagine that you can build a probabilistic model with how often, excuse me, how often different sequences of words occur in your model's responses. So um, the Google's models might have a slightly different vernacular than the OpenAI's models. They might have a slightly different flavor. They might say such that blah blah blah, whereas OpenAI's might say therefore blah blah blah. So there's a lot of consistency in some of these responses in the way the models give out tokens. And let me actually check if that aligns with what Gemini is saying.
Yeah, but I suppose that makes sense, right? Each model would have its own particular way of responding. So, for example, maybe Grok responds with really short kind of not curse, but like curt messages where it might hold no bars in responding, whereas OpenAI's may be a little bit more pleasant, or the Quen model will respond in a particular way. And maybe you just can kind of tell what model each one is. So if you know that, then you could just run a program. And I think it'd be fairly easy to make a program that just goes and then automatically runs on one of these chatbot arenas, and then goes and then upvotes your model, regardless of how it did versus the other one. And I could, in theory, and to be clear, we're not accusing any company of doing this, but like it wouldn't be hard for like anybody to go and then create a program to figure out which model is speaking and then just upvote that. And then, maybe you just run that like 10 billion times. And then you have the best model. So in theory, I bet we could do this. I bet I could like put a model that we make that just like responds like a poop emoji. And then you just like, no matter what, if you see the poop emoji, you just upvote it. And then it's like the poop emoji is the top model that beats all the other models. And
we should definitely do that.
Yeah. I mean, you could do that, right? And then you just are the top model. It's like, it's the poop model. It's very smart. The only thing it does is no matter what it does, it only responds with poop. It'd be very fast. And you could be the top model just by essentially gaming the arena. And actually, that'd be pretty funny if we did.
That's hilarious. It's definitely something the internet would love. And Gemini agrees, not with this, but what I mentioned earlier. Some of the techniques for watermarking include word choice bias, slightly altering the probability distribution of words. So certain words or phrases are statistically more likely to appear if that model is watermarked. So theoretically, a company could embed a watermark in their model, identify which responses are from their specific model in chatbot arena, and then upload that, download all the other models. So yeah, benchmarks, even vibe checks are a useful tool, but not foolproof.
Yeah. So I think we've pretty exhausted everything I want to talk about benchmarks. Now, we've only gone to 2 topics. There's one more topic I want to briefly bring up before we wrap it up. So,
sure.
Google, they came out with a new announcement, which kind of builds upon the Figure AI announcement we talked about. I think it was a couple episodes ago. So, they came out with, I know, I feel like this is a very Google heavy episode, but they came out with a new robot model, and it is based off of their Gemini 2.0 model. So if you remember, Gemini 2.0 was one of the top AI models on the LM arena, and this is what they call is their first vision language action model. So basically, it's a model that is specifically made for robots. So what that means is the robot can see the things in front of it, and it can also understand commands. And then based off the commands and what it can see, it can take some sort of action. So there's some interesting videos where it shows the robot doing particular things, but it'll show the robot do things such as walk around, plug in an outlet into a plug, put away some groceries, and then it can even do things like, put a ball in a bowl if the ball is moving. It could tie your shoes. It can understand the world around you. So there was another example of it folding origami. It can do all types of stuff. And the fact that Google has announced this, and I just am really excited that they're working on something like this. And then another thing they showed in the video is like no matter how much the world is tampered with, right? So in the video, for the video listeners, they're showing the robots trying to put grapes into a bowl, and the guy is like moving the bowl around, and it's able to handle that. So this is going to show that it's able to that we are getting closer to a robot future where the robots are going to be able to do a lot of tasks for us. So it's not there yet, but we're getting close. We're getting very, very close.
And again, remember that we're on this exponential curve. Just because we're close here, that doesn't mean it's going to take us a long time to get to the next stage. We're just going to rocket ship straight up this curve. And there's been a lot of conversations about AGI. We wanted to maybe set that aside for a separate discussion because it does feel imminent. It does feel like we are so close. It's within our reach. And it is really cool to see this paper from DeepMind, because they mentioned how they tried to ensure safety once we reach, and this is going to be a lot more important once we reach like significant capability from these robotics models and we deploy them in the real world, and they're just out and about interacting with people, interacting with other entities. So you want to minimize the harm that they could potentially cause. So they talked about how they built a robot constitution, a set of rules, guidelines that the robot should abide by to prevent any kind of harm to itself, other robots, and definitely other humans. And this is inspired by Isaac Asimov's 3 Laws of Robotics, who is a science fiction writer who has written a lot of very forward-thinking books about the future of humanity, technology, and specifically robotics and sentient robots or intelligent robots. And it is so freaking cool to see science fiction inspire real-world, cutting-edge research.
For sure. This stuff is really exciting. It actually, I don't want to take this conversation too long, but this kind of reminds me that a lot of these advances aren't going to come to the world equally. So for reference, living in the Bay Area, in Silicon Valley, I saw precisely, I think, close to 0 robots at restaurants. I don't think I saw one. But in Japan, I'm actually seeing a lot of robots at restaurants. So there's a restaurant that I go to called Gusto, which has a really good breakfast, and they have like a drink bar. You can get unlimited coffee. It's awesome. And I sometimes will go there before my classes, and I will go there and study and eat a little bit, because it happens to be right by the language school that I'm going to. And so we could kind of get into Japan's societal thing, but Japan has a declining population. So it's like, I think, below replacement rates. And they are really struggling to get enough workers. So they've actually been filling the gap with robots. So at this restaurant, and it's just a regular restaurant, I will go in and it says, okay, please seat yourself. And then I will order whatever food that I want. There's a tablet there, and I'll order at the tablet. And then once I order the food, I will wait a little bit. I'll go to the drink bar. I'll fill it up. It's just a bunch of machines that I'm using to fill up the drinks. And then for the food, there is no human that goes and delivers the food. There's a robot on wheels that will go navigate to my to where I sit. It has the food. Now, it doesn't put it on the table for me. It just has wheels, but it has the food on this. I get up and I go take the food off the robot, and then I hit a button to send it back, and then the robot goes back to the kitchen. And then on the robot, there is a receipt, which I can use to go take to the cash register. And there's no human at the cash register. Japan is a very high trust society. We just go scan the receipt at the cash register, and you just paid there and you leave. So for this whole thing, I could be there and I may not talk to a single human or interact with anybody. It's just completely 100% automated. Now, I know there's humans there because there was one time that the robot didn't bring me a receipt. So I think that probably the human who was making the food forgot to put the receipt on the robot. So I had to go and then use the tablet to call the waiter to ask for the receipt. You know, it's not perfect, but the fact that this is out there and it exists, I mean, the robots are kind of coming for the people's jobs already. And I know it's like, for some reason, not that common in the US, but in Japan, it's actually really common. We see it at almost every single restaurant where you have to interact with very few people. Yeah, I mean, like, I think we're going to start seeing that in a lot more other places in the world.
I think you mentioned a key point there that Japan is a high trust society. I don't know if it's like going to work in the US. It's definitely not going to work in India, where my parents are. I also think Japan has been working with robotics for a long time. So they have that culture where they accept robotics. It's also, from my perception, maybe correct me if I'm wrong, but it's a more antisocial society than America, where customer service, social interactions is a lot more valued. People like their independence. People like their distance, their privacy, and it's entirely acceptable for you to go about your whole day, not interact with a single human being, and be fine with it. Whereas in the US, I think there's a culture of being welcoming, being social, greeting everyone you see on the street, saying hi to people that you walk across, even if they're absolute strangers. Not to mention the service industry, which is run by tips. So they are incentivized to ensure a good customer service, make sure that the customer is enjoying themselves. And so I think, and not to mention the lack of trust, crime in major cities, dishonesty, etc. So yeah, a lot of reasons why it may not scale to every place in the world.
Yeah, so I wouldn't say that Japan, the people in the United States are more friendly than people in Japan. I think that the people in Japan are also very friendly in the United States, but I think the difference that I see is that in the United States, people are like, I don't know how to put it. I think people are like more like fake friendly. So, for example, you might ask like, "Oh, like how are you doing?" But like when you ask how you doing, it's not like, "No, like how are you doing?" Like I actually really care. Typically, it's kind of like, "Oh, how are you doing?"
Reflex.
Oh, it's like "Oh, I'm fine, thank you." And you? Oh, great. And then you go on your day. Like if somebody said, "Oh, how are you doing?" and you said, "Oh, I'm doing bad." You'd be like, "What?" It's not the answer that I'm looking for. But in Japan, if somebody asked, "How are you doing?" it's not like, "Oh, I'm fine, thank you." No, it's like, they would actually want to know like how you actually doing. So,
what is the equivalent greeting in Japan? What would you say if you were walking by a random stranger and you made eye contact and Would you even say something?
No, you wouldn't. There would be no random eye contact made with strangers, and I think partially it's because there's too many people. Um, it's like walking around Tokyo. There are like, I mean, if I like held my arms out wide like this, I'd probably hit three people. So, you got to be like really careful when you're walking on the street. So I think just like due to practicality, you won't just say hi, at least in Tokyo, like in the major city. Now, maybe in the countryside, people might like wave at you or something, because there's a lot fewer people. But I think that in general, unless like you're trying to like start like a real conversation with somebody, you wouldn't just go and then say like, "Hey, what's up?" Like I don't think Japan even really has much of a concept of small talk with like other people. And I think it's similar in like Europe too, where like people don't really make small talk. But in the US, like I'll be waiting in a line or I'll be somewhere and then you just go and then talk about random things. It's like, oh, how's the weather? Did you see the game last night? Oh, let's talk like just random things. Then you never see that again. So I remember I when I think I was in high school, we had a French foreign exchange student who was staying with us for I think she was staying with us for like a month or something. And I remember I was taking her to do some errands. Uh, and I was going to it was like Kinko's. I was going to get some copies made. I started like talking to some people in line, and then I remember then we were like in the car after, and she's like, "Hey, did you know those people?" And I said, "No, I have never seen them before in my life." And she said, "Yeah, but you acted as if they were your best friends for like a really long time. You've known them forever." I was like, "Huh, yeah, I guess so." So I think that each culture, uh, maybe the people are like equally friendly, but I think as Americans, we act like overly friendly, which I don't know is kind of nice for society, I guess. But I think in a lot of other places in the world, they don't pretend. You just don't talk to each other.
Well, I think we covered a lot of topics in this episode, and we should probably call it before moving on to some of the other big things that we'll save for the next episode.
Yeah, sounds good. Well, guys, thank you for listening. And if you're not subscribed yet, please do so. If you made it to the end, you are a maverick and like you are awesome. So thank you for listening. And seriously, if you're not subscribed, please subscribe. Like we're really trying to boost those numbers and leave a comment. Let us know what you think of the episode. If you think we're wrong, like tell us in the comments. Like I would love for there to be a debate about all this in the comments. Because most people who watch are not subscribed. So please subscribe and leave comments, hit the bell button, do the things. And again, we love you. We'll catch you in the next one.
One last note before we let you go. I did want to announce if you're here in the Bay Area or if you're going to be visiting the first week of April, the first Thursday on April 3rd, we will be having a larger meetup event in partnership with Langflow and DataStax. So Langflow is a new agentic framework, a low-code agent builder. And I think everyone has touted that 2025 is the year of agents, and this is going to help you build agents with relatively very little code, even if you don't have any technical experience. I think this would be an amazing, I would say, this is one of the most exciting events that we've hosted that I'm excited for. And it's going to happen in Santa Clara in the South Bay at the DataStax headquarters. They've been amazing friends of the meetup. We've hosted events with them a couple times. DataStax actually got acquired by IBM, which has been trying to get more into the AI game recently. They've had their feet wet with Watson way back when, but now with DataStax, especially Langflow, it's an exciting time. We're going to have a set of speakers. There'll be food, drinks, obviously a bunch of networking with some of the smartest minds in the Bay Area. So definitely check it out, April 3rd in Santa Clara.
Yeah, I think that'd
All
be a
right.
really fun event. But yes,
With that, we will see you in the next one.
all right, sounds good.